Sam, give me a question.
I don't have a question.
You don't have questions. Andy, no questions. Joni, pick me a question.
Let's see. What ratio of time is given to the three phases of database design, analysis, data modeling, and
Whew. What ratio of time is that? How much time do we spend designing databases
for each of the three phases?
for each of the three phases and
Like
systems?
4 sets spent on analysis, less on normalization. That's what he does. And data modeling.
Let's get that normalization thing out of the way. All right. Normalization was a process that was developed when relational database, that theory, first came about, and I forget when Hernandez said it was, 60s, 70s, 80s, 2000s, I forget. Relational databases are still relatively new. There are some new theories, but the process of normalization was created to take old databases and those old structures, or heaven forbid, databases that were written on a piece of paper, or databases that are stored in an Excel spreadsheet, or a Word table, or on index cards, to take those and turn them into an appropriate design for relational databases. That's what third normal form, and the forms beyond third, somebody asked me what's the most commonly, where do you stop? Because they had the book lists third, fourth, fifth, sixth, and then all these other special named ones. All that is in my mind, I hate that I'm recording this because one of them's going to probably find it and come back and hit me. But in my mind, it's overkill. We don't have the time. You're learning in systems, or you will soon. We don't have the time to spend years analyzing the death out of our designs. Third normal form is where I stop. And actually, I don't even go there anymore. What I meant to say in this whole thing, I don't do normalization anymore. When the relational database system, the theory came about, we had a bunch of old databases that weren't relational. Normalization was the process that you went through to take an old database and normalize it. In other words, turn it into an effective relational database. We don't have that problem anymore today. Anybody who's building a database today better be smart enough to make it normalized to start with. The methodology that Hernandez is going to introduce you to a little later, and my version of that, which is a little bit different. If you follow the steps, your database will be normalized. You don't go through a normalization process because the methodology that I'm going to share with you and that Hernandez shares with you results in a third normal form database. So we don't do normalization anymore. I don't think so. We don't do normalization. I don't take somebody's spreadsheet that is obviously not, it can't be, because how do you link tables together in a spreadsheet? Very difficult to do. In most spreadsheets, if somebody stores their data in a spreadsheet, it's not normalized. It's called a flat file database. It's got redundant data all over the place. It's got errors all over the place. Table, one big, huge monster table that stores everything. I don't normalize that. I go through the database design process that I'm going to teach you, and I use that spreadsheet as a starting point. So the term normalization, he talks about them historically, but you'll probably not read it in the rest of the chapters. Because today we don't normalize. We create databases from scratch that are already in third normal form that adhere to the relational database standard, if you will. So when you hear normalization, you should go, yeah, that's right, my database should be normalized. We needed it 20 years ago, 30 years ago, but we don't anymore today. Is that clear? Sort of. All right. How do we do normalization? The answer is we don't. We design from the very beginning to have databases that are normalized, and all normalized means is it's optimized for relational databases. If your systems instructor talks about how to normalize the database, I want to know about it. Now, he's smarter than I am. I'm talking to those of you who have Jason for systems. He's smarter than I am, but that topic to me just isn't worth the time. And we're still many chapters away from that in systems, but this class, it's now. I'm not gonna go through an exercise with you to take an existing database and normalize it. Makes no sense. You'll never do it. So, how much time do we spend normalizing? None. How much time do we spend designing databases? That's kind of like saying how much, if I gave you a new project in Programming Logic Intermediate, how much time would you spend in the design phase if you were doing it properly versus how much time do you spend in the programming phase? I think in Programming Logic Beginning, I said something like 60% design, 20% code, 20% test, something like that. So that tells you 3 to 1. Same kind of thing I think applies to designing databases and building them. Building databases is really simple. It's really simple. It's better, it's better or worse depending on your perspective than SMOP. Simple matter of programming. Building a database, I can teach any Microsoft Office beginning student to do that. I did. The challenge is in all the steps before the design. And you'll see that through the next 2 months, I'm guessing. You'll see how challenging it is to build a database, relational database properly. That's what we're going to learn how to do. I'd say at least 3 to 1. Because if your design is good, building the database is easy. And building a front end, what's a front end? Pardon me?
Dashboard.
Kind of a dashboard, yeah, sort of. When I write my systems, changing classes here, sort of, but this is an offshoot of a systems class. All this stuff used to be covered in systems, but it's too important to be buried inside of one course. It's its own course now. When I design systems, I build a database to store the data. I think Isaac asked in his questions, database, all it does is just fields and records. Yep. Just a bunch of data. Going back to our systems discussion yesterday, for those of you not in my class, I apologize, but you should hear this again when Jason gets to it. We talked about the difference between data and information. A database is just that. It's a base, a store, a place where we store data. We store it in a very strategic way so that it's relational and we can very easily extract it when we need it. But yes, that's all a database does, is store data. Now there are DBMSs, right? What's that? What's the acronym stand for? Good. Database Management System. Notice it said system and management. So it's more than the database. It's beyond that. And that's Access. You've seen this. In Access, you can design queries. In Access, you can design reports and forms. You can do backups and compressions. And that's not databases. Those are tools to help us use those databases. When I write systems today, computer programs today, they are database management systems. It just occurred to me. A front end is a C# program that accesses that database. A front end is a web page that accesses a database. It's what the user sees. Steve described it as a dashboard. Well, not quite a dashboard. It's a little too simplified. When we create in the programming logic class our assignment tracker program, we're going to have this text file. It's got all the assignments in it. But your users, including you, do not want to use that text file because it's not easy to take an assignment that's due and make it done. It's not easy to insert new assignments with just the right formatting and stuff so that we can read it. So we put a front end on it, a program that takes care of that for us in a much more user-friendly manner. A front end to me is a program that lets me look into and manipulate that database in a much more friendly manner than a data sheet view in Microsoft Access. than a text file full of hundreds of pieces of text. The front end is the program that I use. A couple of you asking your questions, why are we skipping chapters like 5 and 6? Aren't those important? Hernandez said you shouldn't skip any steps when you follow his methodology. You got to do all this stuff. And I'm blowing off a whole bunch of chapters. He and I have a philosophy difference. He builds databases that stand alone. They have their own, what's the term I'm looking for here? Integrity stuff built in. Data integrity built into the database. Not me. It's not where it belongs. I don't think so. Those of you, most of you are in programming logic. Again, who am I talking? Intermediate, talking, who's not? In intermediate, just Kathy, right? Yes. Programming logic, intermediate. I showed you briefly this 3-tiered model where there's a data component, there's a business class that you haven't been terribly introduced to yet, and then there's the GUI, the form. The database is that data component. But you might remember I said that all of the logic, the rules for business go in the business class. What's the maximum number of kids somebody can have in our database? What's the maximum age somebody could be? What's the maximum number of products we can order? What's the minimum price? What's the minimum number of delivery days? All these rules, requirements. Now we're back to systems class again. Getting your feeling that all this stuff ties together ultimately? I haven't seen it all completely in this naive package, but definitely links together. Definitely. In systems class, we talked about determining requirements, and that's part of those. But all that doesn't go into the database. Hernandez spends 2-3 chapters telling you how to make sure that every field in your database has a complete set of rules. Doesn't belong in the database. All those rules, we still need them, but they go into the front end. They go into the program. Volker's philosophy, not Hernandez's philosophy. Hernandez's, we could put them in 2 places, and that's not a good idea. If I have business rules in the database and I have business rules in my business class, and then the rules change, ruh-roh, I hope I remember to change them in both places. I don't want to do that. And it works for me. And it works from what I hear from my graduates and from my interns, that it works for Skyward, it works for Sentry. That's the way they do it. So that's the way we're going to do it. A little bit different. Man, that's one question. It took me 15 minutes. That's not good. Now it's lots of questions. So I answered one of Isaac's questions, and I answered questions about data integrity to some extent. Trevor, pick your favorite question.
You kind of touched on it. You often describes design methodologies having no shortcuts.
Mm-hmm.
Do you disagree?
No, I don't disagree. If you follow my methodology, no shortcuts. If you follow his, yeah, shortcuts. Skip back chapters 5 and 6. A methodology is designed, like we said in systems, the systems development life cycle is designed to be a little bit flexible, depending on your circumstances. It's all going on a recording.
I know. I'm sorry.
We put you right in front of it. That's probably hear you more than they do me, but that's okay. The methodology is there for a reason, because a lot of times there's a nice sequence of steps that you should follow. Doesn't mean you can't be flexible. So hard and fast rules, there's no such thing. We occasionally have to break them. When you learn my 10-step process, a lot of times there'll be this cycle we get stuck in the middle, where we loop through them. It's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's often 1, 2, 3, 4, 5, 4, 5, 4, 5, 6, 4, 5, 6. But you got to go through each one of the steps at some point, but not necessarily in sequence. Some of it can be done in parallel if you've got a big enough team. That's why the methodology is there. I used to be in the Air Force. Anybody else in here? Air Force? Ever have checklists?
Oh, yeah.
All the time, right? Why? Because they figured out that this is the right way to do it. Right? And Luke was trained that thou shalt follow the checklist, because if that airplane crashes because you didn't follow the checklist, we're putting you in the next airplane. But checklists were for things much smaller than that. And every pilot goes through checklists. It works for the Air Force. Right? It's very specific. You do it in this order. Luckily, pilots and ground maintenance crews are all very intelligent, and they occasionally go, yeah, I did that. But this doesn't apply. They can do those kinds of things, but at least they looked at it and thought about it. Here we have a little more flexibility. There's no life and death things going on in our software, because we're designing business software. But what runs those airplanes? I hope those people are following a nice methodology for their software, because if the software crashes and makes the plane crash, that makes me nervous. That's very difficult work. Eric, you got a question for me? John?
I had kind of a question about that new internet databases. Since there's more advances like the iCloud and everything, right now everything kind of revolves around relational databases.
Yep.
Do you see that changing?
It has already changed. Good question. Just for the recording, John's question is, now that we've got cloud storage, does that change how we design databases? Do we still use relational databases? The cloud's got not a lot to do with it. Right now, we store our databases on a hard drive. We store our databases on a flash drive. What the cloud allows us to do is store it on the internet. But the database itself, the guts of that database, are often still relational. Usually still relational. It's a very effective model. Somebody remember the year? When was it designed? I want to say 69. That's a 50-year model that we've been using. Doesn't mean it's not going to change. But it must be pretty good. And it is. It's very effective. So the cloud isn't changing the fact that we're using relational databases. It's just changing where we store them. The database that I have for my attendance program is a relational database that's stored on the web. It's running on a MySQL server. Still relational. However, companies like Amazon, Facebook, those big, huge data stores that store everything that you ever entered in them forever and ever, are discovering that relational models start falling apart when global users, millions of users, hit this database at the same time. We just can't retrieve things fast enough. When we've got bazillions of records, that's a real number now. Don't ask me how many zeros it is. You can't count them. There's so many. We've got bazillions of records. Relational databases can be a little too slow at retrieving that data. We are used to, hi, it's me, Steve. Boom. Hi, Steve. How you doing? Here's your orders for the last 60 years. I'm sorry, 25 years. All right. Here's your orders for the last 25 years. And you just got there, and you want that immediately. And you want to know, what's the shipping status of that last one I placed? You and thousands of other people all at the same time. They're discovering that relational databases are having issues with that, because they're huge databases. So there's new philosophies going on there. They use a language called NoSQL. All I know is how to say it. That's all I know about it. I can't imagine any. I've lived relational databases my entire software development career. I can't imagine doing it some different way. So yes, there are other ways, but I can't tell you how it's done, and you won't learn it here. And you're not likely to go to a company like Google, like Amazon, and become one of their database experts. You might get a job as one of their software developers, and you might have to learn how to communicate with one of those databases. But if you do, they'll teach you. If my answers generate new questions, you got to jump in. Otherwise, I'm going to the next one. Go ahead.
In chapter 1, it talks about a data warehouse. Is that the same as the server farms you're talking about from Google?
No. Server farms are big, huge databases.
Okay.
But to me, a data warehouse, when you hear the term warehouse, it's kind of long-term storage to me, right? Our general term of a warehouse.
Is that what the cloud is then?
No, can be, but not always.
So it's more
To me,
archived?
and data warehousing is new. It's only like 20 years old. It's new. We're still trying to figure it out. And I think the author said, when we first got it, all failed miserably because we didn't have the hardware, we didn't have the computing power to deal with it appropriately. Data warehouses are long-term storage of data that's old. Like, for instance, your orders at Amazon for 5 years ago, are they going to keep them on their active servers? Probably not, because their active servers are busy dealing with his order today and his order yesterday versus 5 years ago stuff. And so data warehouses are often where we go park things that we don't think we're going to need much anymore. That's my perception of them. And they could change. Data warehouses also, I'm looking at Val now, I'm going to steal her next question. Val talked about, can't we just create databases that communicate with each other? We? Like you and me? No. Databases internally have tables that are all related to each other. But I have never written a program, I haven't written one, doesn't mean I couldn't, but I have never written one where I have more than one database. Everything I need about that system that I'm building is in one database. We defined a system yesterday as something that's within one business area, right? It's got these boundaries. The data for that is also within the boundaries. But when you start getting databases communicating to databases, for some reason we need payroll to talk to the order system, now you might be talking more of a data warehouse. That's another term, another concept I've seen. If you've got more than one database that somehow need to share data with each other, data warehousing lets that happen. That normally happens because you've archived it. There's a good word. To me, data warehouses are archives. So we put our old data. And I have an old customer database. And I have an old order processing database, and I want to see which orders Steve placed 10 years ago for some reason.
Does TurboTax do that then? Isn't that essentially like a data warehouse? Because when you go in and do your TurboTax now that's
I
electronic.
wouldn't be surprised. You're right. Because if you go to TurboTax and you
It's
want to see
spread out, it's already
last
there.
year's,
Yeah.
you want to see last year's tax return. How does it know it's you? Well, it doesn't have last year's or your 2002 tax return sitting right there ready for you to drag it. When you ask for the 2002, it might take 5 seconds. Oh my God. For them to go dig that up, because then they
These
send a
archive
signal to their
things.
warehouse saying, find me O'Leary's tax return for 2002, and it goes digging, 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 because we've got these huge amounts of data. And ultimately it finds it and brings it back out. My perception of the data warehouse. Data warehousing is supposed to be the newest, latest, greatest thing that there's going to be bazillions of jobs in. Didn't it say that in the systems book? I think. Hadn't happened yet.
Isn't it used for data mining?
Data mining, what does that mean?
Research and sales. And
Data mining, think of why do they call it that? Think of mining. A bunch of people with pickaxes. We're going at our servers with no. We're digging through piles and piles of useless stuff to find what I'm looking for. Statistics. But again, it's all archived, right? Generally archived. Data. Data warehouse. And yeah, now you can go start asking all kinds of questions that you could have never imagined before because the databases are connected and you can do all kinds of weird things. It's another one of those. It really stinks that this is a 2-year program. I really need about 20 years to get you ready to enter this career field if you want to know everything there is to know. And by the way, 4 classes a semester isn't going to cut it either. Let's make it 6 for 20 years. And by the time we get to 20, what's happened to what you learned in year 1? Gone. So you're going to hear this, unfortunately, a lot from me. You're not going to learn that here. We've got 4 semesters, 5 maybe for some of you, to teach you the foundations of IT. And then you go find a job. And you become an expert at data warehousing, web programming, mobile programming. desktop publishing, Java, mainframe programming, who knows? All I'm giving you is the foundation. Data warehousing, beyond the foundation. Hope I've given you a very big picture of it, and I hope it's right, but if it's wrong, you'll tell me about it in the future when you become the expert. All that stuff you fed me in that RDD class about data warehouse, that's not what it is for us. Love to hear about it when you leave. You'll get my standard. I have a new standard answer. Thank you for sharing that information. I will get to it as soon as I have some spare time. So I have 100 students who find cool things and they want to share them with me, but I don't have time to read 100 things. I barely have time to grade 100 assignments, but keep sharing. I have a pile of them. When I retire, I'm going to read them, but by then they'll be out of date, so it won't take me long. Val, I answered one of your questions, sort of, that no, we don't have databases communicating with databases. We want to get everything in one database because that's our business model. That's our system. Is there another one there you want to ask me that's just burning?
I was disturbed with the degree of participation. I didn't understand the concept at all from the book. And
The degree of participation. Yeah, I understand you're not understanding the concept. When we build a database, we're going to have lots of tables. Remember Microsoft Access. We're going to have lots of tables, and those tables in a relational database are connected. They're related. Every table in the database is connected somehow. In your systems book, there was this cloud picture with interrelated components, right? And I said yesterday that if you got a component that doesn't talk to anybody else, it doesn't belong in that cloud. It doesn't belong in the database. Every table is linked to at least one other. Every single one. The degree of participation, is that what you said? I love the words.
yeah, that's
Right. And the degree of participation, before class, I heard the word cardinality. Same thing. Degree of participation. If I have customers and I have orders, how many orders can one customer have? Multiple. Many is the answer that I'm going to ask you to use. So the degree of participation in this, I'm going to put an arrow on it, I don't want to do that, in that relationship is many. One order. How many customers is it related to? One. That says tires, sort of. One car has how many tires? 4, maybe 5 to count the spare, right? That's the degree of participation. How important is your question, right, Val? To me, that's what I want to know. It's either one or it's many. Some database designers are concerned about what's the minimum number of tires you can have on your car. 4, 3. Some little cars run around with 3. 0 tires? You got the hover car already? I want one of those. Right now, the answer is no, it's 4 or 3. Right? And so some database designers will say 3:4 or 5. I don't go to that level. It doesn't matter to me. This is a minimum. That's a business rule. It doesn't belong in my database. This is a maximum. It's a business rule. It doesn't belong in my database. All I care about, let's go up here. One customer. How many orders minimum? Really? Maybe? 0? 1? Can I have a customer who has never ordered anything from me? Depends on the system. It's another business rule. What's the minimum? To me, it's a business rule. It doesn't belong in database design, but I'm really progressive and nobody else goes along with it. Works for me. Very, very well. All right, going with me? That's cool. You don't have any choice. You're going with me. All right, I'm training new database. No, not really. So my degree of participation is either one or many. That's all I want to know. That's all the answer ever is to that question, and I'll show you when to ask the question and how to ask the question. But the 3s and the 4s and the 0s and the 1s and the maxes and the minimums doesn't matter. I don't. So matters one to many. That's it for me. Now, when I say for me, I'm also talking for you. I can complicate this thing. We can talk database design for 6 credits if you want. We don't need to. That's Hernandez's book too. For mortals, the rest of us. You're building a program for yourself. You're building a program for a nonprofit for free, and you're doing it on your own time. We don't need extensive monster database design. We need a relatively simple way to do this that works. It gives us third normal form. That's what I'm going to show you. My levels of participation is just one and many. That's it. Okay? Then you get to Jason's class when he talks about it in systems, and you may change that. What does that tell you? No one way to do it. Like systems, right? How many cycles? 4. Nope. Somewhere between 4 and 3 and 20 and the day of the week and the phases of the moon. How many different ways to write a program? Same thing. There's no perfect way to do this. Jess.
Could you better explain the difference between object-oriented database model and object-relational?
No. For a question for the recording, can I explain the difference between object-oriented databases?
Yeah.
Okay, and what was the other one?
The object-relational model?
The object relational model. The two are related. If you're doing object-oriented databases, then you use the object relatable model, which is just a picture, boxes. It's a little bit different. I've never done it. I can picture it because I know about objects. You're going to learn about them in a couple of weeks in programming logic. I can picture it. Because when you look at a table in the database, my customers table up there, what do I want to know about customers? First name, last name, maybe a middle initial, maybe their address, phone number, gender, age, whatever I can get, right, if I'm a business. What's a customer? It's an object. What I think they're doing in object-oriented database design and database development is tying into what we're doing in object-oriented programming, that front end. But I've never built a database using objects because none of the tools that I use, MySQL, Access, Microsoft SQL Server, none of them are object-oriented that I know of. It may just be a design thing. Don't forget the last time I taught systems, right? 15 years ago. But I told my systems class, I'm a little shocked because the book's pretty much the same. It's been 15 years. Something's wrong. So yeah, that's on my list. I can't give you a very clear perspective. We won't be using it.
Doesn't object-oriented have to do with the belief and how you access
Yes,
the
it does.
So
But it also has then been applied to databases, okay? Where we think objects in databases and how they communicate with each other. Well, that's kind of what I'm doing here. And I'm not doing anything special. When I build databases for every one of those tables that we put into our design, I create an object for it in my business class. You haven't learned that part yet. That's coming. I create an object for it. There's a one-to-one relationship there. For every table, I have an object in my program that relates to it, that manages it, that deals with it. So if I can do it without putting it in my design, how does that fit? So keep that one when Jason starts talking about this, ask him, because he seems to have a better handle on that. And I will ask him in my spare time. Got another one?
Well, I mainly skipped the access portion of my Microsoft Office.
Passed it anyways?
Yeah.
Oops.
And so I mean, I had to make one before, but I didn't really understand what exactly a query is.
What's a query?
And how
Good.
does it work.
Okay. The query is basically a programming command. Right? So how does it work? You write it. Or in Access, you don't write it. You'd say, I want this, and I want this, and I want this, and I want sorted by that, and I only want to see the New Jersey ones for whatever reason. But a query, in English, a query is a question. I have a question about my database. You write a query in a language that you're going to learn in this class. You write a query in a language called SQL that gets you the answer, assuming that you ask the right question. And you follow the syntax. Of course, if you don't follow the syntax, you get syntax error. Really? In data? Yeah. Syntax error is still there. SQL is a language. Structured query language. In my mind, queries get me, what do I get out of my database systems? Information. Okay? The data gets stored in my database, and when I ask a query, it gives me information. Give me a list of the customers who live in New Jersey who have not paid their bills. That's information. That's useful to me. Nowhere is that permanently stored. I ask the question that gives me the answer. It's a good thing it's not permanently stored, because when I ask tomorrow, there might be 3 more people on the list, and a couple of them may have fallen off the list, and I won't be able to ask that question. And get different answers every day, every hour, every whatever. Yesterday, Matt said my book's here in systems. How'd you know?
I called my dad.
You called?
My dad.
Oh, your dad. Okay, information, a new database. I thought maybe he was looking at a tracking number online. As soon as, what happens when they drop that book off? The delivery person goes back to their truck and says, done. It gets shipped to the home office, the mothership, and the database gets updated. You go check online and say, it should be on your doorstep. Why are you looking here? Go get it before it gets cold. Right? You know, today's world, that's amazing. It's awesome. But that's what queries let us do, is ask the question, and then ask it again, and ask it again. I once heard a statement that says the definition of insanity is asking the same question or doing the same thing over and over and over again, expecting a different result. Not anymore. That's normal. Is it there yet? Is it there yet? Is it there yet? Is it there yet? You're asking the same question over and over and over again. You ever written a computer program or used a program and you hit save and it didn't do it, so you hit save again and that time it did do it? Is that insanity? No, that's how you deal with computers. Try again. New answer. Luke, got a question for him? Nathan?
Is it necessary to, well, I'm going to reword this a little, is it necessary to learn the theories of relation databases in full? It says in the full.
All that normalization nonsense? No. Right. There are some very basic, I think they're basic, that I'm going to teach you, theories of relational databases, rules, like integrity rules, and table integrity, and database integrity rules, and normalization, sort of. All of it, I have no clue what 4th, 5th, 6th normal form are, all those other ones with people's names on them. I have no clue what those are. I don't care. It's overkill. It's too much design. Just get in there and build it. If it doesn't work right, fix it. Could have designed it for a year and you would have avoided that one thing didn't work right. Okay, but in the meantime, I built it, fixed it, and moved on. So it's kind of like programming. We learn theory of programming, right? What's a decision? How do we make decisions? How do we do loops? What are functions? Yeah, we learned everything. Do you have to learn everything? No. But I hope in this class to scale it down just barely what you need. What you looking for? Kind of. It's a fuzzy answer. Welcome to IT. You get a nice rock solid answer from an IT person, they're wrong. We learned yesterday in systems about the analysis phase, determine the requirements and look at the alternatives. It's amazing how many IT people skip that. You need the latest and greatest wireless N router with multi-port thingies. I don't even know what all that stuff is anymore. You should be writing this in C#. Why? Because that's what I know, so you should write it. No. There's usually not a straight answer to some of these things. Tim? Oh, Tyler, excuse me. Got the T right.
They said in the book you usually don't want to use multi-part, multi-value, or calculated fields and tables.
All right, whoa, come on. That's not quite a list there. Multi-part,
Multi-value,
multi-value,
or calculated fields.
or calculated fields. What don't I want to do?
Is there ever a case where you would use those?
Sure. Because I just said there's no rules that we don't break. Right? So, yes, sometimes. Give me an example of a multi-part field.
City-state.
Pardon me?
City-state.
City-state. Why would I put those two together? Seems goofy, right? It's a multi-part. It's goofy because it doesn't work very well. What if I want to sort by state? Where did you put the state? At the end or at the beginning? And if I want to sort by that and it's buried at the end of the field, how do I sort by it? That's why we don't do it. One of the reasons. Give me another example.
Phone number, cell phone number.
Nope. Different.
Last name together.
First and last name, customer name, student name. My attendance program. You just asked me if I break the rules, right? My attendance program, student name. Last name, first name. I never want to sort by first name. I want to see my attendance roster by last name. I could split those into two fields, but I just said, yeah, one. That's my program. I get to deal with the consequences in the future. If I ever need to split those, now I got to deal with that. So I can do that. But that's a very classic one that is also today pretty rare. Because most people have figured out that if I do first name, last name, then how do I print it to say, Dear Tyler, in a mailing letter? I want to make it sound very personal. No, it's not, right? How do I do that? You can't. It's very difficult to take a first name, last name, or a last name, first name, and just pluck one of those pieces up. It's much easier just to store them separately, and when you need to, put them back together. That's a multi-part field. City-state zip occasionally shows up that way, but those are pretty rare. First name, last name is very common.
So they had that one in the multi-value, the example of the book.
Really?
So, yeah, so what's.
First name, last name, multi-value?
We had it as calculation. Yeah, it's.
No, I don't care what he says. It's multi-part. It's one field with multiple parts. Multiple parts in it. Somebody said phone number. In the past, I would have said, yes, that's a multi-part field because there's an area code and then there's the phone number. Why would I care about splitting those apart? Because at the time, 10 years ago, everybody had the same area code. And I wanted my programs to fill in the 715 automatically. But everybody's going to do the phone number. But today, everybody got the same area code? Now cell phones are all over the map. So I've changed my philosophy on that. It used to be a multi-part field, not anymore. Area codes are so diverse within one classroom like this, we probably have 5 or 6 different area codes. Does that mean we all live in different? No, it's just cell phones. I've gone back. That's not a multi-part field anymore. It's a 10-digit phone number. 10? What about the dashes? He doesn't want dashes. He wants parentheses around his area. Oh, no. We keep all that stuff. We put the parentheses and dashes in later. So that's multi-part. Can you give me, this one's a little trickier. Can you give me an example of a multi-value field? Okay. Wow.
Like a credit card and an expiration date.
Multi-part.
If you had all of the IT instructors.
IT instructor.
If you had like co-teachers in a class.
Okay.
And
Good.
you had 2 teachers teaching one class.
Okay, so we have a class record, right? We want to keep track of classes, and we want to know who's teaching it. So it says instructor. Well, what if it's team talk? Well, then we put Volker Gall and Catherine Dorr in the same field. Multi-values. 2 answers. My favorite is hobbies. What are your hobbies? Skiing, coin collecting, and Frozen comes to mind for some stupid reason. But anyway, I have 3 hobbies. If I put them all in the same box, if I do, then how do I find everybody who has coin collecting as one of their hobbies? Because it could be at the beginning, could be at the end, could be buried in the middle. Can be done. It's just a lot harder. There's a better way to do it. How do I find all the classes that Catherine Dorr teaches? If she could be the middle, the end, the first instructor, how do we know? That's a multi-value field. It's one field that stores multiple values, but with the same category. Right? When he said credit card expiration date, that's not 2 credit card numbers. It's not 2 expiration dates. It's 2 different pieces of information. But hobbies are all, here's a hobby, here's a hobby, here's a hobby. Here's an instructor, here's an instructor, here's an instructor. All in the same box. Don't want to do that. Takes away a lot of the flexibility when I start showing you my 10-step model, my 10-step methodology. First thing I talk about is why am I doing this? Well, one of the reasons is flexibility. If you put them all in the same box, it detracts from your flexibility. The types of questions that we can ask makes the questions much harder to ask. You need a list of any class that has Catherine Dorr in the instructor field anywhere. It's possible today. It used to be. It's possible today. This is why I said, maybe sometimes I do this. Because I can say, with wildcards, remember those from Access, sort of? With wildcards, I can say, well, if Catherine Dorr's in there anywhere, give it to me. You can do that. Calculated fields. Like what? Classic example for you all, GPA. It's a calculated field. Doesn't that change? No, we used to say, nah, every semester or so, every 3-4 months or so, we'll update your GPA. Today, independent study classes, online classes, late start classes, early start, early end classes, your GPA could change every 2-3 weeks or so. And if Midstate never updates it except every 4 months, you're going, great, I just got an A, that should have bumped my GPA. No, it's calculated. What should happen in a good database is every time you ask, what's my GPA? It goes, ding. And it's always current. So if I email you and say, I just updated your intermediate Excel grade from the IP or from an F to an A, you'll go, oh, cool. New GPA, good. We don't store them, because if we store them, then we have to figure out when do we update it. We don't. Usually, what happens when you graduate? How often does your GPA change then? Most of you are never coming back again. And so at that point, we might create an archive, a data warehouse type storage of graduates. What was your GPA, period? Not calculated. What was it when you left? We store it and it never changes. If you come back, then we got problems. But that's a different issue. I cut you off, Tyler. What's the question? Oh, do I ever change? Do I ever break the rule? Oh, yeah. I put calculated fields in my tables sometimes, but usually it's an archival, it's a history type of thing, where it's never going to change again. If you place an Amazon order and they send it to you, is that order ever going to change? Probably not. So they could then store the order total. Normally you go, how many of these times that price, how many of these times that total, ding. But they can, once that's kind of fixed in time now, then you could maybe change it and lock it in with a calculated field. Today's programs and computers are flexible enough that multi-value is a possibility. Multi-part, I told you. I get lazy sometimes when I do it. It means there's less flexibility in my attendance program. It's mine. Do they do it in the real world? It's not up to you. None of you are leaving here. None of you are going to be database administrators. Promise. That's another one of those jobs that you probably need 3, 4, 5, 6 classes in database management, database design, database administration, and then a few years experience, and then you get the 6-figure salary. But it doesn't hurt to have an understanding of what they have to deal with, and particularly if you're writing your own programs that are database based, so that you can put that flexibility in case you decide to add stuff later. Good. Let's do a few more here. My longest recording ever. Matt?
Can linking tables be used to fix relationship problems?
That relationship problems.
Yeah, because he kind of showed
What kind
an
of,
example.
tell me, Matt, what kind of relationship problems are you having? No, what do you mean?
Because in the book, he used a primary and a foreign key to link a first and second table.
Here comes some more terms, right? Primary key.
Because
And
the linking table only had 2 keys in it, and it was the primary and foreign.
okay. Do I introduce you to this now? Sure, because then I can review it later and it'll sink in. I learned that if I hit you with it, it'll sink in. So, first of all, what's a primary key? Okay.
It's the key that identifies
The field that identifies what?
the first table.
No. What's the real definition of primary key? Yes, sort of. That's not what I'm looking for. Anybody else want to tackle it so I can say no?
It's like the log of information. Like what?
Looking for the term. I'm looking for the definition.
It's for the unique record in each, it's unique for each record in the table.
It's the field. Now, what are fields? First name, last name, city, state, zip, phone number, all that thing, all those things, those pieces of information that we put together to make a record. The primary key is a field. One field, maybe more, usually more. That uniquely identifies every record in the table. So I have a student table. What's the primary key? Student ID. Because each of you has a unique 8-digit ID number, right? Absolutely unique. So if I say, show me the information for student 1, 2, 3, 4, 5, 6, 7, 8, I get Kathy's information and only Kathy's information. That's a primary key. It uniquely identifies a record. It is a field that uniquely identifies a record. I think that's on the terminology sheet. Primary key. So let's go back. How about my customers? What's a primary key?
Credit card number.
Credit card number? Could be. Good.
But that could change. Right?
Sort of. But
It could be
not
like
quite, because my
service.
wife and I are separate customers at Amazon, and we both use the same credit card.
It could be like a service number. Like for instance, if you go to Best Buy, have Geek Squad do something on your computer, you have a service number with the customer number.
That's more for this, but then there's a customer number as well. Where's the customer number coming from? Where's your student ID number coming from? It's just, pick something, right? We're going to learn about auto number primary keys. Every time you add a new record, it gets the next number. Has to be unique. Next number, next number. I don't know why some of yours start with 0, some of yours start with 1, 2s. No clue how they pick your numbers. As far as I know, there's no meaning to them. A customer ID number, it's just a number that my database has picked. To say, it's Steve. Customer number 17, oh, Steve. Because we can now go look in the database and say, give me everything you know about customer number 17. And I get everything I need to know about Steve. I love it when you go to the front desk and you say, I need to drop a class or I need to pay my bill. And what's their first question? What's your student ID number? Let's just tattoo that thing on your forehead. How would you feel if you walked into Ace Hardware here and you said, "Hi, it's me," and they greet you by your ID number? Or they won't even serve you at Applebee's unless you give them your customer ID number. Insane. Why can't they walk up and say, "What's your name"? Why can't they?
Because there may be more than
There
one.
may be more than one. So, how many are there going to be? And by the way, I'm looking at Joni now. There may be more than one. That's one answer. What's the other answer? Joni, what's unique, maybe not unique about you, but what's special about you right now? Your last name?
Yeah.
It's doing this flippy thing, right?
Yeah.
Well, wait a minute. Last week you were Joni Cherney, now you're Joni Johnson. Which one is it? And oops, I can't find you. You're not there. What do you mean I'm not there? Oh, I was called Joni Cherney. Well, primary keys, the best ones, never change. So names are not good primary keys. That doesn't mean you can't walk to the front desk and what's your name, Jeff Strader? Strader, Jeff. So I got two of them. Are you, is this your student? Does your ID end in 27 or 35? Or does it start with? Or is this your phone number? Or is that, now I got you. Not some lame number thing. When Ben Gable walks up, there's only one as far as I can tell. But hey man, hey, we got everything we need by your name, not some number. We're supposed to be student-centered here. Right? You know what we told you? We're student-centered, and why are we asking about your number?
They do the same thing when you call somewhere and they say, "What's your order number?" You know, that's the first thing they want to know is what's your order number.
Isn't that annoying? And you're going, where do I find that? On this, where's my order number? That happened to me. Just recently. What did I order and I wanted to return? And I said, "What's your order number?" Oh, I went into Best Buy, bought my wife exactly what she wanted for Christmas. And then she got another one. Her daughter got her the same thing. So I said, "I'll return mine," because the other ones were already unwrapped. So I returned mine. I take it to the store. And they said, "You can't return this to the store because you bought it from one of our third-party vendors and we can't take it back from the store." "You ordered it for me in the store. What do you mean you can't take it back?" I said, "Can't." Okay. So I go home, I call the 888 Best Buy number, and they said, "Okay, we can help you. What's your order number?" Why can't they ask me what's your name? Spell it, please, DOLKER. And find the most recent order. You're talking about the one you ordered on this date. How hard can that be? It's not. I hate people do it. When we build our databases, the users shall never see their IDs. They will all have them. There'll be an ID for just about everything. They'll never see them. They don't need to. Hate that. Pet peeve, I'm going to be on that soapbox a couple more times. Steve?
We've been doing pretty good with examples of primary keys. So primary keys are fields. Are they always visible? Are they always something that humans can see? Or are they some other magical thing that means only something to the person that created the database?
Or the program that uses the database.
Right.
All right, for the recording, he said, the primary keys, do they have to be visible? Do they have to be, my philosophy is they should be an invisible thing.
Okay.
They are a tool used in relational databases to tie those tables together. When I come over here into this orders table, I want to know who this order is for. It is not going to say Steve Hoffenberg. It's going to say 1, 2, 3, 4, 5, 6, 7, 8. But that doesn't mean that the front end, the GUI, has to say this order is no. That's where the queries come in. We can write queries that says, go into this order, tell me what he ordered, and then go over here, grab the name, let's put those together. Steve Hoffenberg ordered this on this day for this amount. The queries let us put all this stuff back together again in the real world. So, in my world, those primary keys are always hidden.
But they're all fields.
They're all absolutely fields that are used behind the scenes
It's not some special kind of field.
to uniquely identify you.
Are they always numerical?
They're typically numeric, but there's no such thing as always.
Since we're on this topic, I'm gonna bring up my
It's
question.
called a teachable moment for me. Absolutely. Let's go.
Absolutely. Not all of us had the pleasure of having you from Microsoft Office. So some of the Microsoft Office teachers out there
Thank you.
could be somewhat lost when it comes to explaining Microsoft to people.
Okay.
Would you suggest that it's a good idea for us to refresh a little bit in Access? Because I remember a
No,
lot of this. was,
No. Question for the recording is, should you go back and review all that cool stuff in Access? It won't hurt you, but I'll guide you in the proper techniques in this class. Now, Isaac said, I haven't had much in Access, or I skipped that part because I didn't need it to get my B- or whatever he earned.
B+.
Right. Okay, you got a B+ and you didn't touch Access? He said, pleasure for being, you're lucky you weren't in my class, because if you had been in my class, I'd find a way to make that a B- effort. Right. Take advantage.
I did.
Remember what you're here for. Not to get a grade, but to learn. But okay, enough of that harping.
Do you have, any number of foreign keys?
Any number of foreign keys, yes. What's a foreign key? I hate the word key. I hate the word foreign key. It's stupid, especially in Microsoft Access. What do they make you do? Go into the description field and type foreign key. For most people, what does that mean? Nothing. What is it really? I call it a linking field. Its purpose in life is to link this order back to its customer. This order is for Steve. No, it's for 1, 2, 3, 4, 5, 6, 7, 8. A foreign key, by definition, is a field in a table that refers to a primary key in a different table. I got to take that apart, chew on it a little bit before I understand. It links the two tables together. How do I know if I don't put Steve's name in here? How do I know who that order is for? Because I got his ID number, and I can go back here using a relational database system. I can go back here and find out everything I want to know about Steve. If I got this number, I can go in here and say, give me everything you know about 1, 2, 3, 4, 5, 6, 7, 8. There you go. It's all in here. Most of it. Except his hobbies, that's a separate table because that would be a multi-value field, and that's how you fix that. How did we get here? Matt.
Yeah.
Okay, I have not answered his question. Can it resolve relationship problems? There's only one kind of relationship problem that we're going to run into. That's for Val. I smiled at her because that's one of her questions too. This is a many-to-many. This is not a many-to-many relationship. Let's change this to parts. Now we have orders and parts, or products, even better. One order can have how many products on it? Hopefully a bunch, right? One product, a marker, can be ordered by how many different people? Many. That's a many-to-many relationship. Cannot be implemented. Now we're talking physical. Right? This is a logical relationship. Makes sense. But when we try to put it in a database, we can't do it. Where do I put the manys for this? If this is an order, do I list all my parts that I have on that order? How many? 10? 1? 100? If I want to list them all here, I have to have, let's say, 20 fields for here's what you ordered first, here's what you ordered second, here's what you ordered third, here's your fifth. What if I only ordered one thing? I now have 19 wasted fields for that record. Nope. So maybe we should go over here. Which orders have placed an order for this? Oh my God. Think Amazon, right? Thousands of people ordered this book, and I'm going to have 1,000 fields here? No. Ew. How do I fix it? What'd you call it, man?
It's a linking table.
It's a linking table. One of the more complicated concepts we're going to get to. It's a table in between what you didn't see when you were designing this initially. It's called a linking table. It resolves the problem. It fixes the relationship problem. Later. It's coming. But later. And we'll hit all this again. So if it's kind of going over your head, hey, I recorded it. You could pause it and say, let me think about that a little bit. Linking table. There's something in between. We cannot have, put this in your brain for later, we cannot have a many-to-many relationship. We can build it in our design, we can show it in our design, but we cannot build it. Not efficiently. So the solution is that linking table. We'll talk about that again when we get to it. Step 6 or 7 in my 10-step process. Good. Give her credit. These are some of the most in-depth, agonizing for me questions that I've read. Give me a good one.
Okay, this is a terminology question,
Oh, I love those.
because I really want to be able to talk the talk of databases. So, on page 13, Hernandez, he introduces the terms relations, and is it tuples or tuples? Tuples and attributes. And then he says, well, I'm not going to use those. I'll use tables, records, and fields instead.
Did you hear that? It's in the recording. I hope. She said relations, tables, tuples are records, and attributes are fields. Remember when I told you about that worksheet? I said AKA, it's also known as. Which one of those terms do you like better? Relations, tuples, and attributes, or tables, fields, and records?
I like tables, records, and fields better, but then later in the book, like on page 49, uses relations, tuples, and
Yeah, we need a
attributes
4th edition of the book.
again, and then he says, he refers to relations perceived by the user as tables, which made me suspect that a serious database person would use the prior terms. So my question is, if I'm in a job interview and they're asking me to talk about databases, if I start talking about tuples, will I sound really pretentious, or will I sound like I'm informed?
Will that work?
Yep.
Mortals use tables, records, and fields. Your job interviewer, if they're technical, will be mortal, just more experienced than
So
you.
he won't look down on me if I'm using tables, records, and fields. You're just a mere
not want to
user.
work there. Who are the non-immortals? Those theorists, PhDs in IT, computer science, etc., who have to justify their extreme salaries and their ability. They make up new terms. Being serious. It's aggravating. They make up new terms for this stuff. Those can tie back a little bit more. Somebody asked me about the set theory and first predicate stuff. They're not going to care about that either. That's what the theorists used to come up with the relational model. They used math. Doesn't mean you have to understand it. You don't. How does set theory apply into it? We don't care. It was the theory that some genius, well beyond our level of genius, some genius came up with to say, ooh, what if we built databases like this? They would be a lot more flexible and dynamic, and we could add things to them, and we could change them, and it wouldn't be so painful as it was in all those old models. And they said, set theory, and then first predicate order, whatever the heck that means. I don't know. The set theory, I had to suffer through it once, so I kind of understand that, but use it. Use the tool. So, shame on Hernandez for backing off on his statement going, I'm going to use tables, records, and fields. This is 4th edition of the text. I will email him $100. Stopped answering my emails a long time ago, just like Bill Gates. Yeah, you may hear them. You're probably more likely to read them if you're one of those that likes to read online white papers about stuff. You might hear them there. But we're talking mortals here. We got work to do. So I would stick with, you will not hear me use those terms. You won't hear me, I'll use foreign key just because it keeps sneaking in. Hate that term. It's a linking field. I don't like foreign key. Makes it sound like it's written in foreign language, right? Arabic characters or something for my key. No. Where did I start? We're back there, what that one, that's weird. Okay. Aaron, do you have anything left?
Do not.
John?
Mm-mm.
Kevin?
Integrity rules. That's some business.
There, integrity he's talking about. There's different kinds of, different levels of integrity. Okay? Data integrity, the relation integrity you might have heard or remember from Access class. Right? No, it wasn't relational, it was referential integrity rules. Another lower term, referential integrity. Referential integrity says there will never be an order without a customer. Doesn't make sense, right? How could I have an order that nobody ordered? Referential integrity says we build into the database. We don't do that. We put it in the front end. If I write my program right, how could you order something and not put in an order name or a customer name? I'm going to write my program so you can't do that. I could put it into the database, but then if my stupid program let you do it, the program would crash and the database would crash, and we don't want that. Referential integrity simply says that there's no order without a customer. Can I have a customer without an order? Yes. That's different. And we'll talk about parents and childs. Is that in there somewhere? I don't remember reading about parents and childs.
Yep. That's when you get to the ready to read.
Let's get it over with. Or not over with, but let's introduce you to it. Come back to customers. This relationship we said is one to many, right? One order has one customer. It's kind of how you read it. I think Hernandez puts this diamond in here. When you read it, you go one customer and then this one. Kind of skip over that one. And then the key part is you have to read it the other way. One customer could have many orders. I'm going to teach you in extreme painful detail how to do that. Because that relationship, is it one to many, is it many to many, or is it one to one? Those are the only three there are that we can implement, or that period. Unless we get into the complicated cardinality stuff that I said, we're not doing that. Simplifies things immensely and doesn't affect the end result. One to one, one to many, many to many. By the time we're done, all that's left is one to ones and one to manys. Back to parent and child. Who's the parent? Good mess. Why?
They could have many child tables.
Many children,
Yes,
right?
many children.
Parent can have many children.
Yeah.
But a child only has one mother, we call them parents in here. Physically, biologically. The parent is the one on the one side of the relationship, one to many relationship. This is the parent, this is the child. So, it's not really hard. The parent is the table on the one side of a one to many relationship. The child is on the many side. Some tables, just like some people, are parents and children. In one relationship, they're a parent. In a different relationship, they're a child. Perfectly possible. Almost like set theory. We got biology that's stuck in here too. But that's a term that most of us can relate to. The foreign key is the field in the child that refers back to the parent. We've got a lot covered in an hour and 20 minutes. We're almost done. And we're going to hear it all again. It's kind of why I like this format. Right? I haven't even gotten to all these questions you hear yet. I don't know how I'm going to deal with that. If you have chapter 1, 2, 3 questions we didn't get to, bring them on Tuesday. Yeah, see, imagine me. Right? Tuesday, bring them on Tuesday. Just keep bringing them. If they're burning a hole in you, and they should be, bring them with you, and we'll continue our chapter 1 discussions. But I also want to give you the ticket for chapter 4-7. Cancel that. Change my mind. How can you read 4-7 if you don't completely understand 1, 2, 3? I don't think you can. Never mind. No ticket for Tuesday. Volker's, write the date down. There's no ticket on this day in Volker's class, I don't believe it. Alright. So, maybe go back and refresh maybe read those chapters. This terminology, even though it's hateful and painful, it's important. She's right. Karen's right. You've got to be able to talk the language. Now, if you do run into somebody talking tuples, you're wondering why they're watching Mary Poppins, right? Granddaughters, sorry. The whole song about tuples. No, that's tuppence.
Tuppence.
Yeah, close enough. Tuples, tuppence. You know, if you say that, I guess you might be able to look at one. But if you run into those people, they're trying to impress you with their vocabulary. I don't like people. Even in English. I'm an avid reader of novels. If I can't understand the language, my wife, every other word, she's looking it up in the dictionary trying to figure out that's not what I read. You can't tell it to me in a language I can understand, I'll read something else. And so that's just me. Those people, I'm not too worried about them. You're not going to run into many of them. It's going to be tables, records, and fields. That's the same terms we use in Access, right? That we can relate to. We're going to narrow it down, but that's why I'm asking you to do these worksheets so that you can see the alternate names. And if you keep that stored someplace, maybe you can refer back to it if you need to. But Hernandez, he gets away from those, even though he does sneak them in there a little bit. He gets away from them. And you're right. I love when you show me that sentence. It's kind of like, geez, you relate what us mortals would call a table. That's enough. Your brains are full. My recording is full. Rest your brains for 40 minutes. Most of you are back in a little bit. So on Tuesday, my plan is to pick up where I left off. So that would be, well, I got to Kevin, so Kathy. And we'll go around and see what other questions you have. I'll bet you I can fill another hour and a half. Especially since you all bring in these teachable moments. Thank you very much.